Copyright 2014 Math Diagnostics and Intervention, all rights reserved. We're going to take a look at the Pythagorean Theorem, and what the Pythagorean Theorem says is that if we have a right triangle, and let's say this is our right triangle here, and we let two side lengths, the two legs of our right triangle have a length A and B, and our hypotenuse has a length of C, then a squared plus b squared will equal c squared. So what this allows us to do is, if we have any two lengths of our triangle, we can find the third length of the triangle, assuming that we have a right triangle. So let's suppose we have a right triangle. Let's suppose that we have a lovely right triangle, and our side lengths, our legs, are 5 and 12, and we want to find the length of our hypotenuse. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, and we're going to plug in chug. We're going to basically plug in the values for a and b. This 5 matches up with a, one of our legs, and the other leg is 12, and we're going to solve for the length of the hypotenuse. And we get 25 plus 144 equals c squared, and we get 169 is equal to c squared. Take the square root of both sides, and 13 is equal to c. So we just used our Pythagorean theorem to solve for the length of the hypotenuse. Now, there's nothing special about solving for the length of the hypotenuse. I can solve for any two lengths. If I am given any two lengths, I can solve for the third length. It also doesn't matter how my triangle is oriented in space. Let's suppose that my triangle is oriented this way. And let's further suppose that this length here is 10 and this length here is 6. The length here, 10, is my hypotenuse because it's opposite my 90-degree angle. So that's going to end up being C. I'm going to call this 6A, and I'm going to call this length over here B. So the Pythagorean theorem says a squared plus b squared equals c squared, and I'm going to plug in 6 for a. I don't know what b is, and that's b squared, is equal to 10 squared. So I have 36 plus b squared equals 100. Subtract 36 from both sides of my equation, and we end up with b squared is equal to 64. Take the square root of both sides, and we get b is equal to 8. So, given the hypotenuse and one of our legs being 10 and 6 respectively, we use the Pythagorean theorem to find out that the second leg, or the third side of the triangle, was equal to 8. Now, there's nothing special about integers. We can have any length for our triangle. So let's suppose that our triangle is oriented this way this time. Again. And there's our right angle. And let's say this is 5. And let's say this is the square root of 3. Still have the side opposite my 90 is the 5, so that's going to be my C length. This is going to be my A length, one of my legs. I could call it B, but let's just call it A for the heck of it. So now I have a squared plus b squared equals c squared. And we have a is the square root of 3 squared. We don't know what b is. And our hypotenuse is 5 squared. Square root of 3 squared is just 3 plus b squared equals 25. Subtract 3 from both sides of the equation, and we get b squared is equal to 22. Square root both sides, and we get b is equal to the square root of 22. Square root of 22 does not simplify. It's 2 times 11, 22, so I have no pairs to take out. So we're all set. B is equal to the square root of 22. And I can have other lengths for my triangle. Once again, if I have a right triangle, and this time let's orient it this way. And let's say that I have 3 square roots of 7 and 4. And let's find out what the third length here is. So once again, the side opposite my 90 is my hypotenuse, so that will be C. And this side length here, we'll call that one, oh, let's call it B this time, just because we can. Show you that there's nothing special about it being A or B. And we'll call the missing length here A. So once again, A squared plus B squared equals C squared. I have my unknown this time is A, my B is 4, and my hypotenuse is 3 square roots of 7. So I have A squared equals, plus 16, not equals, plus 16 equals 3 squared times the square root of 7 squared. A squared plus 16 equals 9 times 7. A squared plus 16 equals 63. Subtract 16 from both sides, and A squared is equal to 47. 47 is prime, so when I take the square root, A is equal to the square root of 47. It will not simplify any further than that. So once again, the Pythagorean theorem says that if I have a right triangle and I know any two lengths of the triangle, I can use A squared plus B squared equals C squared to find the length of the third side. And it doesn't make any difference if my two sides are both legs or one leg and the hypotenuse. Anyway, I can solve the triangle for the third leg as long as I know any two for the right triangle using the Pythagorean theorem. Good luck.